To obtain iron from its ores, a large and rather complicated plant like this is needed. On the left are 3 hot blast stoves. In the center are the exhaust stack, the charging gear, and the blast furnace itself. But first, let us look at a diagram of this plant. The hot blast stoves. The blast furnace about 100 feet high and with walls 2 or 3 feet thick. The exhaust stack and the charging gear reaching from ground level up to the top of the furnace. These are the main parts of the plant. We'll see now what they are used for. The charging gear brings to the top of the furnace coke, iron ore, limestone. These materials enter the furnace through 2 gas-tight bell-shaped valves. A current of air forced into one of the stoves is made hot by a checkerwork of fire bricks already heated to about 1,000 degrees centigrade. This hot air passes into a bustle pipe encircling the lower part of the furnace, and then into the furnace via a series of smaller pipes called tuyeres. The gases released in smelting pass up through the furnace, out at the top, down into a dust catcher, and are burned in another stove where they heat up the brick checkerwork. Finally, the exhaust gases, containing no carbon monoxide, pass out into the atmosphere via the stack. Let's now look more closely at what happens near the base of the furnace. From the charge, molten slag and molten iron separate. The slag, being less dense, floats on top. It is tapped off at a higher level. The molten iron, being the denser, sinks to the bottom. It is tapped off at the lower level. A moment more to look over the whole diagram before we return to the plant to recognize the main parts. Near the blast furnace are the stockpiles of raw materials. Limestone, broken into pieces half as big as your fist. Iron ore, perhaps from North or West Africa, Sweden, Newfoundland, or from Northamptonshire or Lincolnshire. Coke, about the same size as the limestone. Often, coke ovens are built quite near the blast furnace plant. These raw materials are taken to the furnace top in skips. Here's one containing coke, about 3,400 weights. Now, right at the top of the furnace, 100 feet up. One of the gases produced in the furnace is carbon monoxide. This is not allowed to escape because it is valuable as a fuel and it is also poisonous. The skip tips the charge into a hopper closed by a gas-tight valve. Below this is a space closed by a second valve. The top valve opens, the charge falls, the top valve closes. The lower valve opens and the charge falls into the furnace. It slowly drops down as smelting takes place. The furnace widens to make the descent easy. A large furnace can produce 1,000 tons of iron per day. To do this, it needs some 2,000 to 4,000 tons of ore, 800 tons of coke, 400 tons of limestone, and 4,000 tons of air. This vast quantity of air travels at great speed round the bustle pipe and into the furnace via the tuyeres. The speed of the preheated air leaving the tuyeres may be as high as 6 to 7 miles per minute. They tap the slag oftener than the iron. The number of times depends on the purity of the ore. They tap the iron about every 4 or 5 hours, but before we go to see the actual tapping, let us just glance at a model of the lower part of the blast furnace, noticing particularly the bustle pipe and the tuyeres. Here is the actual bustle pipe. The men are preparing to tap. They are making a channel in the sand. Out of the furnace comes the molten slag. It consists of the limestone and some impurities from the ore. It is led away from the furnace, down cast iron channels protected from the intense heat by linings of sand, until in the end it pours into a slag ladle. This ladle is made of either cast iron or steel. It runs on lines at ground level. The slag is taken away to dumps, later to be used for road making or for the manufacture of building materials. After the slag has been run off, the hole is stopped by means of a plug on the end of a rod. This is known as a dolly. In tapping the iron, the fire clay used previously for sealing the tap hole is first drilled through. Then, oxygen gas from a tube is directed onto the metallic crust that forms at the bottom of the hole. The hot crust burns in the oxygen, making a hole through which molten iron flows out freely into a U-shaped trough of cast iron lined with fire clay. The three men on the left are now withdrawing the oxygen tube. Floating on the surface of the iron is some remaining slag which must be removed. The channel divides into two with a dam and skimmer across. This skimmer holds back the slag which is led off to the right and into the slag ladle. Men remove any slag that gets through. Coke breeze is thrown onto the surface to prevent a skin or skull forming on the iron. From the trough, the molten iron flows into the cast iron channels, again lined with fire clay, a few inches thick, and with a thin covering layer of sand. These channels lead the molten iron into ladles much heavier than the slag ladles and lined with fire bricks. These also run on lines at ground level. The tapping is now finished. A special gun moves into position to force fire clay into the tap hole, thus sealing the furnace again. Smelting continues. The ladles move away, in this case, to take their load to a pig casting machine, which is a mechanical device for making pig iron. We leave the blast furnace now to see the casting of molten iron into pigs. Here on the left is the ladle pouring out molten iron into a channel. It flows down this channel, which soon divides into two, each leading to a series of whitewashed cast iron or steel molds moving on an endless chain. The molten iron pours over into these molds, which slowly pass along, allowing the iron to cool and to set. The whitewash protects the molds from burning. The chain of molds moves up an incline to the right. Near the top, jets of water spray onto the pigs to complete the cooling. From the molds, the pigs fall into rail trucks waiting to carry them on to the next stage of manufacture. Down the chute they come, the small ones about 40 pounds, the large ones about 120 pounds of iron. Some are dumped in the yard. No, they're not dull things, they're exciting. For here are mechanos and motor cars, bicycles and bridges, steam engines, needles and pins, all to be made from pig iron, smelted from iron ore in the fiery blast furnace.